Imagine you are walking down a dark street and hear a sudden noise. Your heart pounds, your palms sweat, and you are ready to run. This is adrenaline and the fight or flight response. It is not just a feeling, it is your body's emergency survival mechanism designed to keep you alive. Today, we are going to break down exactly what happens inside you during these critical seconds. So what is this phenomenon? The fight or flight response is a physiological reaction to terrifying threats. Its primary goal is simple but vital: to mobilize energy for immediate action. Whether you need to fight off a predator or flee from danger, your body instantaneously prepares to exert maximum physical effort. This response is a masterpiece of coordination between two major systems of control. First, we have the nervous system, which sends fast electrical signals for an immediate response. Working alongside it is the endocrine system, which uses slower chemical signals to create sustained hormonal effects. Together, they ensure the reaction is both instant and lasting. To understand the nervous system's role, we look at the autonomic nervous system. Think of it as a car. The sympathetic nervous system acts as the gas pedal. It activates the fight or flight response to speed everything up. Conversely, the parasympathetic nervous system acts as the brake system, responsible for the rest and digest mode when danger has passed. Every operation needs a commander. In your brain, this is the hypothalamus. It serves as the central command for autonomic functions. When a threat is perceived, the hypothalamus instantly activates the sympathetic nervous system, sending the signal to prepare for battle. The process begins with step 1, threat detection. Your sensory organs are the scouts. Your eyes and ears detect a threat, such as a loud noise or sudden movement. This raw data is the spark that lights the fuse of the entire physiological chain reaction. Now we move to step 2, the neural relay. The command leaves the brain as an electrical signal traveling down the spinal cord. This signal hits the sympathetic nerve chains, activating them like a row of falling dominoes, spreading the alert to the rest of the body. This neural signal calls for reinforcements from the endocrine system. The target is the adrenal glands. Located atop the kidneys, these small organs are the factories that release emergency hormones into your bloodstream. Let's look closer at the adrenal gland. It has two distinct parts. The outer layer, the adrenal cortex, releases cortisol, which manages the long-term stress response. However, for immediate danger, we rely on the inner core, the adrenal medulla. This releases epinephrine and norepinephrine for that immediate fight or flight kick. Epinephrine is more commonly known as adrenaline. This is a fast-acting hormone that floods the bloodstream. Unlike a nerve signal that hits one target, adrenaline targets multiple organs simultaneously, telling the entire body that it is time to perform. Adrenaline doesn't work alone. It works with noradrenaline, also called norepinephrine. This chemical has a dual action. It functions as both a hormone and a neurotransmitter. Its specific job is to increase blood pressure and heighten your alertness, sharpening your focus on the threat. Now let's see the effects, starting with the cardiovascular system. Adrenaline causes your heart rate to increase dramatically with stronger contractions. Consequently, blood pressure rises. This mechanical surge is necessary to move oxygen and glucose quickly to the tissues that need it most. Simultaneously, the respiratory system transforms. Your breathing increases to allow for rapid oxygen absorption. Deep inside the lungs, the bronchioles dilate, meaning your airways widen significantly. This ensures that every breath pulls in the maximum amount of oxygen possible. Where does all this oxygen go? To the musculoskeletal system. Blood is actively diverted to the major muscles, while non-essential functions are sacrificed. Glucose and oxygen rush to your limbs to provide maximum power for action. You are now physically stronger and faster than you were moments ago. Your sensory system is also enhanced. Your pupils dilate to let in more light, heightening your peripheral awareness. At the same time, your hearing sensitivity increases dramatically. This allows for better threat detection, ensuring nothing sneaks up on you. To save energy, the body performs a strategic shutdown called the inhibition of non-essential functions. Digestion slows or stops completely so that blood can be diverted to the muscles. Additionally, your perception of pain is significantly dulled by the adrenaline rush, allowing you to fight through injury. None of this works without fuel. This leads to the role of glucose mobilization. The liver begins to break down glycogen stores rapidly. This releases a large glucose burst into the bloodstream. It acts as immediate fuel for your muscles and your brain, keeping you energized and sharp. Eventually, the threat passes. As adrenaline subsides, you hit the aftermath, the crash. Your body feels exhausted and shaky due to energy depletion. Step 5 is recovery. The parasympathetic system activates, slowing the heart rate and restarting digestion, while cortisol works to restore equilibrium. This system evolved for predators, but today we face modern stress. Unfortunately, this response is now triggered by daily non-life threats, like emails or traffic. This chronic activation means our bodies never fully rest, which causes anxiety and disease over time. Understanding this mechanism is the first step to managing it.